Hi, everyone. Welcome to the MLOps Live webinar series. We're thrilled to have you join us for our session today about Home Credit International's journey to MLOps efficiency. I'm very pleased to have with us today Jiri Stewart, Enterprise Architect at Home Credit International. Jiri started his career as a developer, later became team lead and then architect at Home Credit International. He's experienced in financial services with banks, in telcos, and he has a large variety of companies under his belt. He began his ML journey in university with a focus on statistics, neural networks, combinators, etc. And we're very pleased to be hosting him on MLOps Live today to be talking about his journey with MLOps and specifically referring to MLOps efficiency, which we all know is a topic of much concern for many companies in today's economic climate. I'm also pleased to have with us today Yaron Haviv, Iguazio co-founder and CTO. Yaron has much experience in the fields of data, AI, machine learning. For that, Yaron is also the initiator of Nucleo and MLRun, two open source frameworks that he built and today are maintained by the community. And he's going to talk to us about the traditional approach to MLOps versus the production first approach, which also affects MLOps efficiency significantly. So in terms of agenda for today, we're going to start off talking about the challenges of operationalizing machine learning. We'll hear from Jiri about his team's journey to MLOps efficiency. We'll talk a little bit about the different approaches, and then we'll open it up to Q&A. So feel free to ask us your questions. You can do so as the session progresses in the Q&A panel below, or ask us at the end during the Q&A session. We'll take most of the questions live and we might answer a few in writing. So feel free to just ask away. During the session, we'll run two polls. These polls are really important to us. We want to hear from you. We want to know where you are on your MLOps journey. And these polls also help us make these sessions as valuable as possible for you. And we'll make sure to share the results at the end. We know everyone's always interested to hear the results. So please do take part in our polls. That's it. I'll now pass it over to Jiri to get us started.
Thanks, Sahar. Right now I have a problem with the electricity. Sorry for that. The light is turned off. But
it makes it even more interesting.
yeah. Sorry for that. It is not planned. Okay, if you can click on the next slide. Yeah, let me say something about Home Credit International. HCI as Home Credit International is global consumer financial provider, founded in 1997, headquartered in Europe, in the Czech Republic. And you can see the main activity in 7 countries, mainly in Asia. You can see Vietnam, India, Indonesia, and Philippines. Home Credit International serves over 100 million of the customer. Okay, it is quick introduction. Fine. Next slide, please. Yeah, thanks. Let me describe the HCI journey to MLOps with focus on the efficiency in 5 steps. I'm going to present the current position of machine learning in financial institution, main pain points for efficiency view, the key areas for improvement details, and finally, delivery outputs. Yeah. Financial institution and position of machine learning from the helicopter view. We can split this view to the 2 parts. The first green part is about the financial view, and you can typically see 2 financial budgets. One for investment, which will be used for profit generation, and second budget for risk reserves. Budget for investment covers for OPEX, CAPEX, and PEREX, price of money. It means interbank interest rate. And you can finally see money intended for lending, which will generate income and profit. Budget for risk reserves cover requirements based on legal and regulatory, quality of risk management, and you can see here direct relation to client defaults. In this financial view, the risk management plays the key role. You can see that the client offers has strong relation to the quality of risk scoring, which define client interest rate and balance the risk versus possible profit or loss. The second blue part of this picture is about a process view. The typical covers these areas: part acquisition, selling services, product servicing, collection processes, regulatory reporting, and accounting. From these 5 steps, the regulatory reporting and accounting are mandatory, and the rest of steps has significant relation to the machine learning model. What does it mean in reality? What is the key differentiator between the good and the best financial institution? All is about the ability to deal with the risk, where machine learning models and data play the key role. Very strong factor is power of this model and efficiency to bring this model to the production. Next slide, please. If we focus on the typical use cases for machine learning, then you can see many cases. Let me mention a few. Campaign management, where we would like to identify the best consumers for our products. Case, product offers, it means define default and pre-approval limits. Case, risk-based pricing with balance between the attractive products versus product security, which relation to co-applicant, insurance, product, and so on. Case, also next best offer for cross-selling with prediction of next best action, and also case collection and pre-collection strategies based on the client behavior for risk reducing. You can also see cases for supported areas such as anti-fraud. It is about a client protection, where you can see information from device fingerprinting, such as mobile device scan, malware detection, and so on. And also support topics are such as bill client behavior profile based on power prediction from data mining. You can typically see that many companies focus on the main use cases, risk-based pricing and collection, and then later they are focusing on other areas such as campaign management and anti-fraud. From workforce point of view, you can see tens of machine learning models where you have to cover not only model development, but also model monitoring and tuning in time. These models can be affected based on evolution of the market, client behavior, political situation, and based on new opportunities. What does it mean? Short conclusion. It is definitely about a huge effort if we would like to stay in top of level competitors. Next slide, please. About the main pain point. When you visualize typical delivery cycle for machine learning, you can clearly see the pain about time spending for specific tasks. The significant effort, 60%, is primarily on side of cleaning or organizing data. It is joint effort of data strategy, data management, and governance. Second significant effort, 19%, is on the side of collection dataset. The rest of 20% is more about core task where you can find data mining, building training dataset, model training and testing, and so on. It means that 80% is about the data preparation, and this effort significantly prolongs efficiency for delivery. Next slide, please. The second bigger pain point is about a total delivery time, and you can see the results of surveys experience. Gartner survey showed that the delivery time in 2020 was about 9 months on the average, and more than 70% of response reported that the delivery time was even 1 year or longer. You can see that bigger companies are, the longer delivery time is. And I got also confirmation based on my survey, see right part of this slide, that many companies expected this logical ordering. The main priority is access to the data. then proper machine learning environment, then team size and knowledge, and then other things such as legal requirements, GDPR like GDPR, security roles and restrictions. It means that the key problem is not only about a long time for specific tasks, see previous slide, but a bigger issue is delivery of complex solution to the production and the view to the whole chain. Next slide, please. Thanks. Based on previous slide, you can see the gradual way for improvement of the HCI efficiency. The first step is about access to the data. It means building data strategy, use structured, unstructured, semi-structured data with direction to federated virtual data. The second step is about the delivery proper environment for the machine learning with focus on the automatization and operation efficiency. The third step is again about environment for machine learning, but with focus on performance. It is about elasticity, serverless, and hybrid solutions. The last step is about support, team size, and knowledge sharing. Other steps are not public right now and drive future way. Next slide, please. What does it mean in detail to start this improvement? The data strategy is the enabler for the delivery. This data strategy usually contains current state, future architecture, and transition. We covered in the current state our position and maturity, cross data governance, data quality, technical solution, and so on. We identify detailed pain points, bottleneck, and missing capabilities. We define for a future state relation to the business vision and requirements, and relation to the trend, opportunities, and best practices. Finally, we describe transition way. It means the steps for delivery with milestone and conditions. This first steps, access to the data, is practically an enabler for delivery of the next steps. Next slide, please. First bundle of improvement is focused on the time to delivery and covers easy integration via federated query and integration to online and offline sources. You can imagine online sources such as Kafka, message queue, REST API, and so on. Under offline sources, you can imagine access to the HDFS, object storage, and so on. The next point here is standardize and sharing. It is about a model and data sharing. You can see here a strong position of the feature store. Also, important point is component and repository sharing. The last point is automatization for code, data, and models. You can see here topic not only continuous integration and continuous delivery, but also continuous training and monitoring via pipeline and hyperparameters. Next slide, please. The second bundle of improvement is about the operation and elasticity. You can see here impact to the on-prem and cloud environment. You can see here Azure, AWS, Google platform, including business continuity management with exit strategy support, ability to use different hardware, bare metal, virtual, CPU, GPU, and so on, support different file systems, HDFS, object storage, focus on the maintenance support, backup, archiving, cleaning, also cover enterprise security, single sign-on, identity management, role management, security information and event management, vulnerability checks, and the last but not least, data management, such as central data catalog, data quality, data lineage. Also, the elasticity is important point in this way, and you can see here zero downtime, scale up, scale out, auto scaling, including threshold, throttling, current Python code scaling, very important point for many companies, and functionalities supported complex unit processing such as event aggregation, fix, and flow time windows. Next slide, please. What can we expect based on this improvement? You can see as delivery output these three main metrics. First, reduce time for delivery from 3 to 6.6 times. This range is based on the different complexity of machine learning models. Second very important point, 60% of reducing for total operation cost. And the last point, 20 times reducing of the storage capacity. That is all. Let me do short summary. We identify a strong position of machine learning models in financial institutions. We identify key pain points for improvement efficiency, and we defined a way for improvement contains focus on the data strategy as the enabler for and focus for the automation, performance, and knowledge sharing. Thanks for your attention, and it makes sense to focus on the pool of the question. Sarah, the stage is yours.
Thank you so much, Jiri. It was fascinating to get an inside look at what's happening over at Home Credit International and a very detailed deep dive into the types of items that you're considering and looking at as you build your MLOps efficiency. So thank you for sharing all of that. We really appreciate it. We'll just pause there quickly for our first poll, and we'll launch that right now. We want to hear from you where you are on your MLOps journey. So let us know, is this the first time you're hearing about MLOps? Are you researching and learning more about MLOps? Are you actively looking for an MLOps solution, or have you already implemented an MLOps solution? Right, and with that, I'd like to hand it over to Yaron, who is going to be speaking about MLOps efficiency from the production first perspective. Yaron, the stage is yours.
So thank you, Sahar. And thanks, Jiri, for the insights. And I think later on we'll open it up to the questions. So some people will have things to ask about real production, real deployment in your experience. But before we're diving into it, so some things that we've seen recently when we're working with many companies that adopt MLOps is this, people are talking about MLOps, but still treating the world as sort of two different silos. One silo is the silo of data science, where you do MLOps, but more in a very basic level. You're using MLOps as a way to train the models, potentially do some experiment tracking, configure your training environment or your development environment. But once you've built the different artifacts, the models, the training code, etc., then there is a separate effort, which is to build the production systems. This is where you build the machine learning application itself. So machine learning application is this thing that uses the model, does some data preparation and processing, some prediction, does some actions, and so on. And also all the code that was developed in the first phase is essentially being refactored. Potentially it was done in Jupyter notebooks or basic code by data scientists, and now ML engineers or software engineers are taking that code, refactoring it, adding Docker files and YAML files and configurations, making sure it runs, adding exception handling and adding security, sometimes turning code that was done for a standalone system, moving it into something more scalable like Spark or Horvath or other frameworks. And then there's all the aspect of continuous operation, continuous deployment, CI/CD, model monitoring, and so on. But because those two different things are developed as silos, so you will see there is a lot of re-engineering that happens here, which wastes a lot of time and a lot of money. Go next, Sar. And really where we see the more advanced organizations moving towards is looking at it as one problem where there is a collaborative effort by different team members, whether these are the data scientists or data engineers or the ML engineers, software developers, and so on, to build something continuous. So whatever you're building in the first phase needs to go to production. So if you build a training function, you need to make sure that you handle testing and you handle exception handling and you handle scaling that code, etc. If you don't know how to do it, you can submit the code and let someone else take the same code and add some functionality and commit those changes back into a repository. Next time you want to make additional changes, you take that code that was already sort of matured and factored with operational aspects into it, and add the additional data science functionality to it. So that's the flow that we're seeing there. And another thing is a heavy dependency on automation. So instead of building manual processes that take notebooks and refactoring them, etc., building the code in a way that, adding automated testing, adding serverless computing to turn the code into something that deploys in production, adding monitoring, and so on. And this approach of creating something that is dealt with the entire team, not just the data scientists as a separate team or the engineers, but sort of a team that works together, coupled with automation, deliver several key ingredients. One is ability to drive products much faster to production, much better use of resources, both human resources and computation resources. So not wasting time on re-engineering, but rather working together. Delivering much higher quality with this approach. Again, scaling to bigger scales, lower latency, higher performance, but also aspects of the model. By applying more testing and more automation, you can improve the quality of what you're building. You can explain what you've built. You can explain why the model behaves in a certain way. You can roll back to previous versions in case of failures. So you bring much higher quality. And you can deliver continuous application improvement. That means that if you need to add another feature, it's relatively easy. You just go to the code base, make this small change, the automation, the automated testing, the automated deployment will do the rest, and you can deliver those incremental changes very quickly into production. Next. And the approach that we chose to implement to allow this model of operation where you have the different personas, the data scientists, the data engineers, the ML engineers, software developers, all work on one framework, everyone with his own traditional set of tools. If data scientists likes to work in PyCharm or Jupyter, they can do that. If data engineers like to work with BI tools or SQL, that's another option. And if you want to work with Kubernetes and Kubernetes assets as a DevOps or MLOps engineer, that's okay as well. You all need to work on one platform, and you need to apply automation to deliver the different components into production. So within MLRun, what we did, we divided the functionality to 4 main categories. One is for developing the features. Usually the data is one of the toughest problem that you need to deal with, and that was also what was referred to by Jiri. And this is where you use a feature store that takes those analytical pipeline definitions and converts them to production pipelines automatically. The next thing is to build sort of an automated CI flow for taking the data set, doing validation on the data set, training, testing, and so on, building a model, and then later on deploying that model as part of a multi-stage application. And finally, having a component to monitor the activities of the models, the scoring, identify drift, rewrite the production data into the system so we can use it for retraining or further analysis, and so on. So this is where we build a production system using serverless functions and using Kubernetes as sort of an underlying infrastructure. Can you click? But the important thing is that developers don't need to understand what Kubernetes is and what is automation and all that. They can work with their traditional tools, whether it's a Jupyter notebook or PyCharm or VS Code or some cloud framework like SageMaker or Azure ML, or if they're using traditional CI/CD tools like GitHub or Jenkins or other things, they could just keep on using those things, and through APIs and SDKs, those things are integrated into the automation framework that builds the production system. And this is really the concept behind MLRun. Next. So if you look at the traditional flow where you're building some code in your IDE, and then someone else takes that code and builds, all the testing infrastructure and YAMLs and Docker containers and so on, and then someone else takes those components and build workflows and pipelines, multi-stage workflows and pipelines for either the training or the application stage. Later on, you need to start adding instrumentation. This is a very manual, very siloed process with a lot of re-engineering and a lot of delays. And with the process that we're suggesting is essentially you have the code in your IDE, you call an API call, which automatically translates it to a managed service. You take those managed services, you compose pipelines from them, and you build applications and ML pipelines. And the instrumentation is essentially built in already as part of the SDK. You don't need to add things to do model monitoring or data validations and so on. This is all built in. So if you'll have problems, those problems will float immediately, and you could apply automation, like retrain your model if there is a problem, or explore the production data as a data scientist and see why it behaves in a certain way, or maybe take insights from the production. Next, Sarah. And the way that MLRun essentially works is it has those four main components. It also has the central metadata layer and those serverless functions that are under the hood, taking those workloads into production automatically. But it has those four clear pillars, and we suggest that you go to the MLRun documentation and you learn more about those. The first part is the feature story. So again, MLRun has four main components beyond the generic frameworks of serverless and central metadata database for all your machine learning objects and metadata. And those four pillars that you have are, one is the feature store, where it automatically builds features for online and batch and training. It has the real-time application pipelines, where you can build graphs that translate to online multi-stage applications. So you can do things like data preparation and scoring and actions and monitoring in the same application flow. You have the monitoring and the retraining framework, so collecting data from production and analyzing it and applying actions to it. And finally, the CI/CD, which is automating the flow of taking a data set, validating it, running training, testing the trained model, etc., and integrating with the different CI frameworks like Jenkins or GitHub and so on. Moving to the next slide. So you can learn a lot more in MLRun. It continues improving on a daily basis. There's new documentation. There's actually a new release coming up tomorrow, as far as I know, like 1.2. And you can see there's new documentation divided horizontally by use case, like training or serving or monitoring and so on. And you also have by component, the deployment. You have many tutorials. There's like a dozen tutorials by now for every aspect of the flow. All of these are from the last few weeks. And you have many different deployment options that you can see here, anywhere from a local Docker for more of a testing the water. It's not really for production. You have deployment over Kubernetes. You have lots of new documentation on the installation process. You can also use CloudFormation templates if you want everything to be fully automated. The CloudFormation is not just MLRun; it packs a lot of additional components like Kubeflow and integration with S3 and Grafana and Prometheus and all those different tools that you may need for building a framework. And if you don't want to work, you can just call Iguazio and we'll get you a managed solution with the same options. So with that, back to you, Sarah.
Thanks so much, Yaron, and thank you for sharing the production-first approach with us. It's really interesting to see how this ties into MLOps efficiency. There's a lot of questions in the Q&A, so we're going to get to them in just a minute. But before we do, we're going to do another quick poll, and we want to hear from you how you handle MLOps efficiency in your organization. So I will launch that now, and please do let us know. Do you use MLOps orchestration? Do you use a feature store? Have you built an in-house solution to handle all of this? Are you on the lookout for a good solution? Or perhaps you're not at the scale where you're concerned about MLOps efficiency yet. And now to the interesting part. Let's take some questions. So it looks like the first question is for Jiri. Could you run through a specific project, share a little bit about the ML models in production, and speak about the architecture and how you achieved it?
Okay, let me answer on it. Do you hear me? Yeah.
Yes, yeah.
If we focus on the detail about this first project where we are starting, we are focusing on improvement of risk-based pricing and focus on the next best offers right now. It is about the enrichment of our sources which we are using for the building of these machine learning models. And as I mentioned at the beginning, we started with the approach to prepare the relevant data and to build data like and use this data directly from this source ideally via federated query. And as the next steps, we definitely would like to focus on the data mining, identify the next powerful predictors. And finally, we would like to join this online and offline effort for the building of the model. And it means in the offline, we would like to identify the new predictive power items or predictors, enrich model. And finally, we would like to use serving from the online for the execution of this model. It means MLRun can help us with the covering of this both way. It means focus on the offline and focus on the online. But as I mentioned, it is joint effort of the data lake together with a huge automation from the side of machine learning and MLRun solution. And it is what we would like to deliver.
Excellent. Thank you, Jiri. This next one is for you, Yaron, about MLRun. If running in cloud and using SageMaker or Azure ML or Databricks, how does MLRun plug into that ecosystem?
So MLRun is essentially an orchestrator, and you can actually build a pipeline in MLRun that launches the jobs in Azure ML or in SageMaker. We're also working on plugins for Databricks. You can mix and match. So essentially, MLRun can also run Spark jobs. MLRun have serverless Spark built into it. So if you build your own Kubernetes cluster and you want to use Spark and not necessarily go and use the Databricks service, you can do that. And one thing that we're working on is also a plugin that it can execute the Spark jobs on the Databricks service. But for SageMaker and Azure ML, there are examples and tutorials. So you could, for example, use MLRun Feature Store and then use AutoML in Azure ML or SageMaker to do the training. And once the model is generated, MLRun can grab it and build it into an application pipeline. So you can essentially mix and match all of those. This is part of their key advantage is the openness, because essentially you can take MLRun as an SDK, install it in SageMaker or in Azure ML or in your own Jupyter. It doesn't lock you into a single environment.
Excellent. Thanks, Yaron. Another one for you, Jiri. What are the challenges you've seen and expect to see when forming and running teams who can deliver ML projects end to end? So data preparation, model building, deployment, monitoring, etc. It's a great question.
Yeah, the main challenge for me was about the automatization. It is definitely easy to imagine that you have all data in the data lake and you would like to use it. But the added value is automatization to focus on the MLOps, build the pipeline which prepare you the data. And it is not only about automation testing, but it is also about automation monitoring, because finally we would like to save the effort for the not only the building model, but for the maintenance of these models. Yeah. And typically, if we focus not only on the typical scenario as the risk-based pricing, but next best offer, next best action, and so on, you can see really many of the models where you need to focus on, together with the point of view on the maintenance. And from this point of view, it is a huge effort, and without the automatization, it is a huge problem to cover everything. And as Yaron mentioned, if we focus on the MLOps framework, we have ability to, for example, build only one pipeline which will cover the both scenario for the online and for the offline. And it is also very helpful for us how to save the time and how to be more efficiency. And based on my presentation, the key added value was definitely the reduced time for the delivery. Yeah, because if you will be able to deliver, for example, more than one project during the 10 months, but deliver, for example, 2-3 different machine learning projects, focus on not only the risk machine learning project, but also cover the CRM, anti-fraud areas, and so on, you will be definitely more efficiency and you can improve the added value of the company.
That's really interesting. Thank you, Jiri. We're getting a great mix of technical questions and questions that have to do with the team and with the organizational structure. So I love this. The next one's for you, Yaron. How does MLRun compare to MLflow?
Yeah, I think there is a one before the.
Oh, do you want to take that first? Yeah, I'll read it out.
Exactly.
You mentioned data scientists, data engineers, MLOps engineers. Did you experience a challenge in defining responsibilities, and whether there were more overlapping cases where all of them were expecting to do certain things like data preparation or model building, because this is a common and persisting problem in building and running ML teams? Another great question.
So essentially, by defining the sort of the contract between the different components, as well as creating automation, you eliminate those challenges. What do I mean? Like, for example, if a data scientist builds some data preparation code, and you could automatically turn that data preparation code that was used in a Jupyter notebook and works in small scale with a CSV file, you can automatically turn it into a pipeline that uses Spark and takes now data from a data warehouse like BigQuery or Snowflake and works automatically and does the same business logic, just on a much more scalable machine. You eliminated a lot of that challenge. Or as Jiri just said, if I can turn it into a real-time pipeline that sits on Kafka on one end and generates updates to a key value store on the other end without changing the logic, then essentially I can eliminate a lot of that challenge. And if I create a contract that I'm saying, okay, data scientist builds a feature, and now maybe the data scientist really doesn't care about validation policies and bias and things like that. He just wants to get some features for his training, but he has a contract of how to define those features. He builds them and it works. Then he can move on to the training, and another guy, the data engineer, for example, can take that definition, say, you know what, but you didn't validate the data well enough, or you didn't clean it in the best fashion, etc. So the data engineer can take that component and continue working on it while the data scientist works on the other component. And that's the case with all the other components. If we build contracts between one component and another, for example, you're training, you're delivering a model. The model is not just a pickle file. The model also contains metadata about the schema of the data, about expected behavior of the data, etc. The guy that takes that model into production and deploys it as part of the application pipeline now doesn't, essentially has all he needs to move to the next phase. So you eliminated the need for a glue logic. You allow them to work decoupled. You allow them to work in an incremental fashion. Potentially, again, the data scientist can build a serving pipeline just to test, to try it out, to see that it works. And the production guy can say, you know what, but if I work with GPUs, it's maybe more efficient. Maybe I'll work with spot instances, it's more cost effective, etc. So again, if we're dividing the responsibility on one end and creating contracts between one component and another, and the other thing, we apply more and more automation, we make this team a lot more efficient. If they also work on the same platform versus one guy working on Hadoop and another guy working on Jupyter and a third guy works on Kubernetes, if they all work on the same ecosystem with the same metadata databases, with the same APIs, it makes it much more collaborative and more efficient.
Absolutely. Would you like to talk a little bit about MLRun versus MLflow? And there's some other names here.
So they're really
Kubeflow, Argo Workflows, Luigi.
Okay, so let's start with MLflow. Again, there may be some overlap between MLflow and MRun, but they have totally different goals. MRun is an end-to-end orchestration layer for machine learning and MLOps. It's not necessarily a tracking system. MLflow is mainly started as a way to track your experiment. It's really component in the interactive, experimentation phase. Maybe there's also some ways to define some metadata, etc. in MLflow, but it's more for interactive development. It doesn't apply automation. MLflow doesn't automatically create serverless functions, doesn't run your job and try, and make sure they don't fail and all those kind of things. There's no CI/CD in MLflow. For example, if I want to build an automated CI/CD pipeline, there's no such thing in MLflow. There's no feature store in MLflow. Okay, so all those there's no serving pipeline, there's just potentially serving endpoints. You can take a piece of model and put it behind the REST API. What about the data preparation logic before that model? What about exception handling, model monitoring, etc.? That's not part of MLflow. So MLflow is a great tool for when you're trying to experiment and track those experiments and show nice charts of like which experiment did what and graphical comparisons and all of that. But that's not a tool that's going to save you time to go to production. Now, MLRun does have some of that functionality as well. So in MLRun, you also have experiment tracking. Actually, we're moving more and more to what we call auto MLOps, which means that you don't even need to instrument your code. If you look at it, we have some comparisons around a code using MLflow and a code using MLRun. In MLRun, the idea is that you don't need to write any code, potentially maybe one line of code just to add some imports. But we're trying to automatically add the MLOps and the logging functionality without requiring you to even add a single line of code for parameter parsing or logging and all of that, which you need to do with MLflow. Another key thing is that in MLflow, you would use MLflow for the development, but then for production, how do you use MLflow in like a production, distributed training environment, and so on. That's I've seen a lot of people try and build a lot of extra glue logic on top of MLflow. MLrun does it automatically. It works whether it's running interactively or whether it's running in a single container or when it's running fully distributed. It automatically knows how to fit itself into the environment that is working. So that's, I hope I addressed the question.
Yeah, definitely. Thank you. Let's see. Okay, a question here about continuous machine learning. It is indeed very interesting to learn about continuous machine learning framework. It probably falls under offline machine learning. I would like to learn more about online machine learning, if possible. It's someone who needs it for one of their current projects. So either of you, do you have some words to say about online machine learning?
Maybe let me say a few sentences about that. In our cases, we would like, for example, to deploy to the production more than one models, and based on the parallel execution, we would like to see how the original model perform against some other competitors' models. And from a point of view of the automation, I can imagine that if we will train one model during the time based on the online data, we can challenge the original model, and it definitely brings us the added value to automatically simulate in the production what can happen in the second or third scenario and so on. Yeah, it is definitely a challenge which we would like to cover in the time.
Excellent. Let's see. Another question about MLRun and Iguazio. So Yaron, I think this one is for you. In terms of data versioning, formats, and data labeling, does Iguazio support these? Working on an open innovation mental health initiative, little standardization in the industry. Can you say a few words about that?
Yeah, so first, everything in MLRun is version, whether these are data objects, feature sets, feature vectors, models, everything has versioning. I actually have two different versioning schemes, like a Git repository. You have like the SHA, or the unique identifier of a version. You also have like tags and labels, so you could give certain object a version like production or development. You can change those. So that's on one end. So again, everything is version. In terms of labels, there's also the aspect of labeling for the training set. And you could, there are many different tools that do the labeling manually, and we integrate with them. There's also approaches to do automated labeling. Think like of a stream of data that arrives and has all sorts of metadata, about the movie, about the time things have taken, who's inside the picture, etc. So you can also build applications that while data is ingested, it essentially adds labels into the data. Actually, we have a complete section in my book just about different approaches for automated labeling. But I'm not sure if you're referring to that or to the version of the data itself. But we can take it offline further. But in general, MLRun does support versioning for every object and continuous operation for those.
And Yaron, can you say a few words about model registry / Metastore as a part of MLRun? And does the feature support both training and inference, batch and real time?
So the short answer is yes to all of those things. And part of the development of MLRun started as a very big initiative for modeling machine learning by multiple companies, including Google and Microsoft and others. So we've essentially made sure we model all the different objects, whether it's a feature and a model and a data set and execution and artifacts and so on. And all of those things are managed by MLRun. The nice thing about MLRun, again, you don't have to use all the components, that you have a feature store and you have the sort of the development phase and the serving and monitoring. But if you do, then essentially it's a common metadata across all. So you can train the model using the training function, and it will automatically generate a model artifact without even having to write code. You can tell the system if you want this model to be compressed using Onyx or in different formats, but it generates a model object and registers that automatically in the registry. When you go to the serving, you don't need to add metadata. You can just point to a model object in the registry, and that model object already contains schemas and metadata and information about its properties and accuracy and framework and all of that stuff. So essentially, a single click can deploy that model. Unlike if you're working with two separate frameworks, you need to essentially write glue logic that takes from one, adds metadata, and writes it to the second. The same for model monitoring. What is essentially model monitoring? Is comparing information that was gathered through training, like from the training set or the sample set, comparing it with the production data sets and see if potentially there's a deviation on the statistical behavior of the data and so on. So all that metadata that is used in training is essentially recorded automatically in the model. So when the monitoring system essentially gets a model to monitor, it has all that data. You don't need to tell it anything. It essentially gets the metadata of the training information and histograms and statistics about the features. It grabs data from the feature store about those features, and it can essentially compare all of those. So all those different permutations saves a lot of glue logic and a lot of extra engineering work. And yes, MLRun supports real-time serving and batch serving and supports real-time data engineering from like Kafka and HTTP and so on, and also batch data processing.
One note, if I can.
Yeah, of course. Go ahead, Jiri.
From perspective of the data point of view on the data, when you typically use data lake, where the data is not properly organized as in the DVH, and you need to use directly this data to the model, you are definitely missing some logical layer where you can describe or properly define the predictors, powerful variables, and so on, and also keep this information in the time, track it, this information, and so on. And definitely this part is fully covered based on the feature store. It is one important, very, very important point, because in other case, it is very, very hard and not possible to manage the development of this model. Primary in the case that you need to create a model in the time, and you need to also compare the performance of the model. Yeah. From the historical point of view, if you don't work with the feature store, you have typical two cases how to cover this problematic. One is that you need to periodical parse of historical data and try to calculate the historical values of the predictors and compare this output with the new calculation of this predictor in the new model. It is one way. Or you need to build your own some meta information and so on. But definitely it is your own solution, which can be costly. But based on the using of the machine learning platform, MLOps with the feature store, you have this layer, this glue automatically. Yeah, it is by default. And definitely it can save many of the time. Typically, if you use a huge amount of data in the data lake, for example, 0.5 petabytes or few petabytes, only this calculation can save you a lot of the time, definitely. Yeah, thanks.
Yeah,
that's a great point.
The GPU question, that's short. The question, does MLRun know how to deal with GPU? It actually has great support for GPUs. When you launch jobs or real-time functions like serving and data processing, you essentially just say turn on GPUs. You can even specify how much GPU or CPU ratios you want to do. And when MLRun builds those underlying serverless components, it knows how to configure the GPUs for optimal usage. It also automatically addresses the API. So if you run a training job and you request a GPU, it configures the CUDA drivers, all those things automatically for you. So you can seamlessly move from with GPU, without GPU, with essentially a single flag. You can see that some of that there's a demo of image recognition, of mask detection. It actually shows how you essentially, with the flip of a parameter, you move from distributed work on multiple GPUs to just running things locally without a GPU.
So while we're on that topic, there's another question here about MLRun. Does MLRun orchestrate on Kubernetes as operator or classic Helm chart?
So MLRun is multiple services. It has UI, it has orchestration, it has security, RBAC, single sign-on, lots of different components. But it also has operators underneath. So essentially, when it launches a Spark job or when it launches a real-time serving function, it's using operators, essentially those serverless engines, which are taking a request and turning it into a live service. We have operators like Nucleo, which is for real-time. We have operators specific for multi-stage graphs, for online multi-stage graph called serving. We have Spark operator, Dask operator, Forward for deep learning. There's like 8 different operators under MLRun, and it's pluggable. We can add more of those in the future. It also gets deployed as Helm charts. If you go through the installation instruction, you'll see that MLRun installation is using Helm charts, but you can also use things like CloudFormation.
That's great. And Jiri, perhaps you can weigh in on this one. Could you imagine a way of involving end users in the model building process? What tools or methods would you use for such an idea? Similarly to agile software development, where representatives from the end users are involved in the process. Any thoughts on that?
Yeah. Typically, I can imagine that if you focus on the agile, you have 2 weeks, the sprints. Yeah, it is typically a period for the building of the new version of the model and get the revision from the end user. If we will use this automation and if we will use, for example, canary testing with the ability to build not only the current decision logic in the machine learning or current machine learning strategy, but different, that you can typically get really quickly the feedback from the end user, how this new model will generate added value. But it is important to thinking about the type of models. If you focus on the model, for example, for the next best offer, you can relatively quickly see the impact of this new model to the production and the reaction of this end user. But if you would like to use the same result on the model, for example, for the risk-based pricing or for the focus on the default of the client, then you probably will not be able to see this answer immediately. Because typically after the few months, half years, or 1 year, you can finally see what does it mean, this behavior of the clients from the default point of view. Yeah, this period for the testing is a little longer, but definitely, if it is possible, and if you will do the proper automatization, you will be definitely catch this release cycle from the agile, and you will be able to involve the user for the real testing of that. It is definitely our aim to be more quickly. Yeah.
That's really interesting. Thank you. We'll just take 2 more questions because we're nearing the end of our time. There's one here about on-premises. I think this one's for you, Yaron.
Yeah, so a quick answer is yes, MLRun supports on-premises. We have, I think, 40% of the deployments or so are installed on-premises on VMware or on sort of a KVM Linux in a Red Hat environment, and it just integrates with an on-premises Kubernetes. Actually, it has a lot of things for on-premises, including secure environments that are built into. I think there's another question here around installing over Kubernetes. So essentially, the Guazio MLRun service essentially runs on top of, depending on the cloud, GKE, AKS, or EKS, depending on the cloud. So obviously, MLRun can work. There is documentation on how to install MLRun on a Kubernetes environment. If you need something more, and for Amazon, you also have the CloudFormation. We're working on the equivalent of CloudFormation for Azure and Google. But if you have specific questions around AKS, we can shoot them over the Slack channel, MLOps Live, or through LinkedIn. We can connect you with some technical resource.
And we'll share the link in the chat in a moment.
Yeah, or you can even open an issue in the Git of MLRun, and we'll have someone answer that.
Great. And last question, quite quickly. How would we use MLRun for batch sizing and the configuration of real-time streaming? And is there a tutorial for an adaptive learning pipeline?
We haven't.
That's a big last question. Yeah.
So for like batch prediction and things like that, there is a tutorial including like drift analysis for batch. There are also few tutorials on real-time streaming for like NLP and for like regular machine learning, and as well as image recognition. I'm not sure about the adaptive learning pipeline. I don't think we have a tutorial, but again, that's something we can take offline. Jiri, do you have any idea for adaptive learning pipelines?
I think the tutorial on the side with documentation is the best. I think it is step-by-step scenario how to do that. It is relatively easy, and the main part or core part is based on the machine learning model from the end user. Yeah, because the rest is this glue which define this efficiency. But I see this way how to do that. It is easy link on the documentation, I think.
Yeah, I think another point, because MLRun is designed for a real operational pipeline and not just for interactive usage, the way it looks at data is a continuous stream. So when you're starting to work with the feature store, for example, you're saying I want to train, but if you want to do retraining, you essentially need to say I want to retrain on a window of, for example, last week worth of data, because the data keeps on pouring. You don't retrain on all the data all the time. Then essentially this allows you to build a sort of adaptive learning pipelines. Every time you can train on a window of data that sort of revolves around a certain time window, and keep on training and potentially, because the MLRun also supports things like ensembles, etc. What we see is people deploy multiple models, not just one. So maybe you'll have one model that covers the last few weeks, which is more of a temporal model, and another model which is seasonal that covers the same time last year. Okay, because there are certain changes that are happening because this is what happens last week, but there are certain changes that happen because this is summer or holiday season and so on. And you could measure the model monitoring allows you to actually measure every leg of the ensemble, so you can see which part of the ensemble is more accurate, and you can change the weights and things like that to give it more impact.
So we're going to pause there because we're right at the end of our time, and we did promise to share the poll results with everyone. So let me just pull those up now. The first question was, where are you on your MLOps journey? And you can see that most of the attendees are researching and learning more about MLOps, more than 50%. 23% are actively looking for an MLOps solution. 23% have already implemented an MLOps solution, lucky you. And 3% are hearing about MLOps for the first time. And it's interesting to see as we do more and more of these webinars, this number goes down. MLOps is really becoming a term that's quite familiar, and that's great. And those of you who are just learning about it, you came to the right place, and we're happy that you're here. The second question was about MLOps efficiency, and this is also very interesting. So if you look at the results, you'll see that 30% have built an in-house solution, which is incredible. 42% are still looking for a good solution. That's not surprising at all. 24% are not yet at the scale where they're concerned about MLOps efficiency, and 3% are using MLOps orchestration. So that's also very interesting. And thank you again for participating in the poll. At this point, I want to invite you to check out our MLOps page on iguazio.com/MLOps. There's plenty more MLOps resources for you, blogs, videos, glossary terms, previous sessions of the MLOps Live webinar series where we hosted other MLOps experts like Noah Gift and experts from Microsoft, GitHub, AWS, and many, many more. So please do check those out. They're all available on our website for immediate download. We also invite you to check out MLRun. It's a community project. We love it when people try it out, give us your feedback. If you like what you see, feel free to star our repo. That always makes us very happy. And you can check it out right here. The link is also in the chat. And at this point, I just want to thank Jiri and Yaron so much for joining us today and for all of your amazing insights and for answering all of these questions online. And thank you to the audience for asking really incredible questions and engaging in the conversation. And please do join our Slack community, MLOps Live, to continue the conversation there. Ask us your questions, and we'd love to hear from you. So thank you so much for joining.
Thank you also. Bye.
Thank you, Sar. Bye.